Java also supports compile time polymorphism to make your code faster and cleaner. With compile time polymorphism, we can have more than one method with the same name. Let's take a look. With the conditional array list, we can create a new list with a predicate. In this case, the condition is if the number is divisible by 3. We can also create a condition array list by providing a series of numbers in addition to the predicate. Only those that satisfy the condition will be added to the list. We are able to use the constructor in this way because the second input in our constructor is a variable argument. So this is our constructor and this is the argument. You can input 0 number, 1 number or many as you want. However, they do have to be in a series or array format. If you want to add another list or collection to the condition array list, it's currently not available. In fact, when we try to get an error saying, let's say I'm trying to add an array list to my condition array list. So right now there is no array list added to our constructor. So it will start showing an error because the array list is not provided in our constructor. To solve this issue, we can implement compile time polymorphism with method overloading. What we will do is add another constructor in our condition array list with the input as array list. What we are doing here, we are adding another constructor with the same name but give it a different set of parameters. With this, it will have to have the same name and return type, or else the method wouldn't be overloaded. It would just be a different method. Since an array list works a little differently, we will need to modify some of the implementation for streaming through the list contents. We will write super array list. So predicate, this is the condition and I am passing array list here because I am using array list in my next condition. So I'm going to use super array list. We will stream through the content, then I will filter it. So the value is predicate. We also need to add that as parameter. Great. We have overloaded the constructor method by adding a second method signature with different parameters. This will allow us to construct a condition array list with a predicate and an array list. If you want to have multiple ways to create or manipulate an object with different sets of input, method overloading provides a way, and we will see this in our main method. Going back to the main class, the error has gone away. We have used compile time polymorphism to initialize our condition array list in different ways. In fact, since a condition array list is another form of an array list, we can further this by initializing the instance with a different condition array list. For example, let's say we have another predicate is divisible by 6 with the new condition, that is, we could use this predicate and create a new condition array list is divisible by 6. So how does Java decide which constructor to use? It based on the input types and the number of parameters used at the compile time. Hence compile time polymorphs. We can continue to expand our overloaded constructor by having one call the other. Instead of having our constructor take in an array list, it can take in a list, which is more basic form. So I will update it to list. We can use that because this form guarantees that the stream method which is used on the list will be implemented. In fact, it simplifies our implementation because now we are dealing with a more basic object, a plain list, rather than the more nuanced and complex array list. We don't use functionalities specific to an array list, so why should that be the input type? From here, we can have the other constructor use this functionality by calling it directly. So I need to create another constructor. From here, we can have the other constructor call this main constructor, that is the condition array list constructor. This constructor will be called by this constructor. Now this constructor is calling this constructor. Now the filtering as well as setting of the condition is all done in one place, making our implementation more maintainable and leaving less room for error. Furthermore, the overloaded constructor makes our code more flexible, giving us more ways to use the same functionality.